How does a single particle cause 3D print failure? Imagine building a delicate sculpture layer by layer, each one perfectly placed. Now picture a tiny speck of dust or a microscopic particle sneaking in. That small intrusion can cause big problems. In 3D printing, whether using filament or resin, the process depends on precise control of material placement and curing. When a foreign particle enters the environment or the material itself, it can disrupt this balance in several ways. First, a particle can get trapped between layers, creating a weak spot or a gap. This flaw can cause the layers to not stick properly, leading to delamination or cracks as the print continues. Think of it like a small chip in a glass. It weakens the whole structure. Second, particles inside the nozzle or filament path can block or partially obstruct the flow of material. This results in underextrusion, where the print becomes thin or incomplete in certain areas. In resin printing, floating particles can interfere with the light curing process, causing uneven or incomplete hardening of the resin. Third, particles on the build surface or the first layers can cause uneven adhesion. If the initial layers don't stick well, the entire print can warp, detach, or shift during printing. Even a tiny speck can make the nozzle skip or drag, creating surface defects or misaligned layers. Fourth, because each layer depends on the previous one bonding correctly, a small defect caused by a particle can cascade. A weak spot can cause subsequent layers to peel, collapse, or warp, leading to a failed print altogether. From a reliability standpoint, a single microscopic particle acts like a tiny fault line in the structure. It compromises the overall strength and durability of the finished part. To prevent this, strict cleanliness is essential. Regularly cleaning the build plate, using high-quality filament or resin, and maintaining nozzles and resin vats are key steps. Using filters or sealed environments can also help reduce airborne particles. Monitoring print parameters closely can help catch early signs of issues caused by contamination. In the end, a tiny particle can cause a big failure because it interrupts the flow of material, weakens layer bonds, or causes uneven curing. This highlights how sensitive additive manufacturing is to even the smallest contaminants. Keeping everything clean and controlled is the best way to ensure your prints come out perfect every time.